Hi everyone, hope you all are doing great. So, today we're gonna learn about Unit 4 Microprocessor, subject code KCS 403. Myself Sakshi Arya. I am doing my BTech in CSE from GL Bajaj Institute of Technology and Management in Greater Noida. So, today's agenda is firstly, we're gonna learn about what is assembly language, programming model of 8085, what is instruction, types of instruction. In types of instructions, we get to know about data transfer instructions, arithmetic instructions, logical, branching, looping, counting, and indexing instruction. And in last, we're gonna learn about how to make a program to add three numbers. So let's get started. So, what is assembly language? An assembly language is a low level programming language for microprocessors and other programmable devices. Assembly language uses a series of mnemonic codes. What are mnemonic codes? Mnemonic codes is a programming code that is easy to remember, which helps us to write our code in an easy manner because machine language uses zeros and ones to perform an instruction. So it's difficult to learn the sequence of zeros and ones. That's why we use mnemonic codes. Now we get to know about how we convert assembly language to machine language. So basically, microprocessor cannot understand a program written in assembly language because every device, programmable device, work on machine language. So to convert assembly language to machine language, we need a program which is known as assembler. With the help of assembler, we convert our code into machine code, which send that machine code instruction to the system, and then system execute that particular instruction and perform task. Now we learn about programming model of 8085. In 8085 we have accumulator of 8-bit, flag registers of 8-bit, but only 5 flag registers are in use and the other 3 registers are in don't care condition. Now we have 6 general purpose registers which are B, C, D, E, H and L. All general purpose registers are of 8-bit in size. Then we have some special purpose registers which are stack pointer and program counter. Both of them are of 16-bit in size. Now let's discuss about all these components in detail. So firstly we have general purpose registers. We have 6 general purpose registers which is B, C, D, E, H and L. The size of general purpose registers is of 8-bit in size. These registers are used to store or copy data using data transfer instructions. Data transfer instructions are those instructions which help to perform the data transfer between registers or the between register and memory locations. Now, general purpose registers can be used as register pair also to do manipulation of 16-bit data. Sometimes we have data of 8-bit or 16-bit in size. So for that, we can combine two general purpose registers together to store the 16-bit of data. But we have some sequence to pair the general purpose register, which are BC and DE and HL pair. We can't rearrange them according to our cell. So we have to follow the predefined pairs. Now next we have special purpose registers. In special purpose registers we have flag register. The flag register in 8085 microprocessor is a special 8-bit register that contains the status flags. Basically, the status flags are the flags which tell us about the status of the result which we have after performing arithmetic and logical operations in the accumulator. We use status flags to see is there any carry generated when we perform an operation, is there the result is in zeros, and much more. In flag register we have firstly sign flag. Sign flag is set when the result of an operation is negative, which means the MSB of the result is 1. On the other hand, if the result of an operation is positive, in which MSB of the result is 0, then the sign flag is reset. Then we have zero flag. Zero flag is set if the result of an operation is 0. Otherwise, the zero flag is reset when the result of an operation is a non-zero. Suppose we are performing subtraction between two numbers. If we subtract two numbers, we can have 0, either negative or positive. So if we have result in a zeros, then the zero flag is set, otherwise it's reset. Then we have auxiliary carry. In short, we call it AC. Auxiliary carry flag set if there is a carry from bit 3 to bit 4 during an arithmetic operation involving the lower 4 bits of a byte, otherwise cleared. Suppose we are doing some operation like sum of two numbers. If there is a carry generated after the third bit, then the auxiliary carry flag is set, and if the carry is not generated, then the value of AC flag is reset. Now we have parity flag. Parity flag set if the result of an operation has an even parity, which means we have even number of ones in the result. On the other hand, if we have odd number of ones in the result of an operation, then the parity flag is reset. Then we have carry flag. Carry flag is set if there is a carry from the most significant bit or the MSB, which is 7th bit, during an arithmetic operation, otherwise the value of carry flag is reset. So now we have second special purpose register, which is accumulator. Accumulator is an 8-bit register and it is used for performing arithmetic and logical operations between the two operands. The result of an operation is stored in the accumulator. Accumulator is also identified as an A register. Now we have third special purpose register, which is program counter. Program counter plays an important role while executing an instruction, because for executing an instruction we must know the address of the instruction. It is the first step while the execution. So that address is stored in program counter. Program counter register is a 16-bit register and identified as PC. The function of the program counter is to fetch the 16-bit address of the instruction from the memory location, and then program counter register incremented by 1 internally once the instruction is fetched. The value of program counter incremented by 1, which means when the current instruction is in decode step, then it fetch the second instruction and store its address in it. Now we have stack pointer. Stack pointer is also a 16-bit register. Stack pointer can be used as a memory pointer. The programmer will load the 16-bit address memory location to the stack pointer, which will be the initial address of the stack. Programmers can use push and pop instructions to insert or retrieve data from stack memory. Basically, when we run any instruction whose address is stored in program counter, when program counter sends that address to the instruction register, Then it fetch the next address of the instruction. Then stack pointer store the previous address which is stored in the program counter, because if somehow the previous instruction is not executed properly, so the program counter get back to that address to perform the execution of that previous instructions. So stack pointer is also plays an important role. Now what is instructions? Basically, an instruction is a command given to a computer processor that specifies a specific operation or task to be performed. It guided it guides the processor in executing tasks such as arithmetic operation, data transfers, logic operations, branching, and more. Now we have instruction types. There are many instruction types. The first one is data transfer instructions. Data transfer instructions are the instructions which are used to transfer data from one place to another, for which we have many commands like move. Move command is used to move data from a source register or memory location to a destination register or memory location. Then we have MVI. This command is used to move an immediate 8-bit data into a register or memory location. In MVI command, we just give the data, not the address of the data. Then we have LXI. LXI is a command which is used to load a 16-bit immediate value into a register pair. When we have X in the command, it is used for register. Then we have LDA. LDA is a command which is used to load the accumulator with data from a memory location. STA command is used to store the content of the accumulator in a memory location. Then now we have arithmetic instructions. Arithmetic instructions are the instructions which are used to perform operations like add, subtract, decrement, increment, and much more. So firstly we have add command. Add command is used to add the content of a register or memory location to the accumulator. Sub. Sub command is used to subtract the content of a register or memory location from the accumulator. Then we have INR. INR command is used to increment the value of a register or a memory location by 1. DCR. GCR command is used to decrement the value of a register and memory location by 1. ADC. ADC command is used when we want to add any content of a register or memory location to the accumulator along with the carry. Then we use ADC command, because sometimes when we perform an addition, then there is cases that carry must be generated. So then we use ADC command to add the carry in the further addition. Now we have SBB. SBB is a command which is used to subtract the content of a register and a memory location from the accumulator along with the borrow. When we do subtraction between two numbers, there must be a need that we need a borrow to do the subtraction. So then we use SBB command. Then we have third type of instruction, which is logic instructions. Logic instructions are the instructions which are used to perform and or compare operations. Firstly, we have AND command. AND command is used to perform a bitwise AND operation between the accumulator and a register memory location. When we have two numbers and the both numbers have the value of 1, then only it generates one result. Otherwise, it generates zero result. ORA. ORA is a command which is used to perform a bitwise OR operation between the accumulator and a register memory location. In ORA command, when we have single 1 is present, then the result is also 1. XRA. XRA command is used to perform a bitwise XOR operation between the accumulator and a register and memory location. XRA command is give one output when we have two different outputs. Otherwise it give 0 when we have same numbers. Then we have CMP. CMP command is used to compare the content of a register memory location with the accumulator. CMP command is basically used for comparison between two values. Now we have fourth type of instruction, which is branch instruction. Branch instructions basically used from to jump from one location to another. So we have JMP command, which is used to unconditional jump to a specified memory location. Suppose we are performing an operation in which we have some conditions that after fulfilling one condition we have to jump to the another one. So there we use jump condition. Now we have JC. JC command is used when the carry flag is set, and there is JNC command is used when the carry flag is not set. JNC is just the opposite of JC command. Now we have JZ command. JZ command is used if the zero flag is set. When the zero flag is not set, then it jump to the given location. So there we use JNZ command. Now the fifth type of instruction type is looping. Looping is used to instruct the microprocessor unit to repeat tasks. A loop is set up by instructing MPU to change sequence of execution and perform the task given. This is accomplished by jump instructions. Basically, we use loop when we have to make a program in which we have various conditions that we have to perform same instructions again and again for a particular time. So there we use looping instructions. There are two types of loops, which is continuous and conditional. In continuous looping, we repeat a task continuously, and in conditional looping, we repeat a task until certain data conditions are met. The sixth instruction type is counter. This programming technique uses INR or DCR instructions. A loop is established to update count, and each count is checked to determine whether it has reached final number, or if not reached, then the loop is repeated. Suppose we want to make a program in which we have to write print a table up to 10. So we use counter there, which decrement by 1 after each iteration. So we use counter when we want to print a limited values. Now we have seventh instruction type, which is indexing. It means counting or referencing objects with sequential numbers. Data bytes are stored in memory location, and those data bytes are referred to by their memory location. Basically, indexing is the address of the data where it is stored. So now we have program to add three numbers. Here we use MVI A, comma 1 to H. Here H is used for hexadecimal numbers. So 12 is a hexadecimal number here, and MVI command is used to move data 12H into the accumulator immediately. Same with the MVI B 13H command and MVI C 05H command. We have moved the 12H in A, 13H in B register, and 05H in C register. Then we add B. Add B command add the content, which is 13H of B register, into the content of accumulator, which is 12H, which perform 12H plus 13H, which gives us 25H. So now we have 25H value in the accumulator. Now we have ADCC. Here ADC command is used to add the content of register C to the content of accumulator along with the carry. So here when we do 12H plus 13H, a carry is generated. So now we have STA200H command. So this command is used to store the result of accumulator at memory location 2000H. Then we have HLT. This command is used to halt or terminate the program. Now we run this command on the GNU Sim 8085 simulator. So here we have the same program, but here we are taking decimal values to understand the concept easily. So to check our command have any error or not, so we use assemble here. So after running assemble, as we can see, program assembled successfully, which means there is no error. So there are two ways to execute a program. We can directly execute it from here, or we can execute it step by step. So firstly, I think we should go for step by step to understand the concept easily. So we use this tab to run our instructions step by step. So firstly we have MVI A, 12H. Yeah, so as here we can see, there is MVI A 12. So now we run step by step. Before running, we have to save our file. So I'm saving it with add. Yeah. So here, first command MVI A, 12. This command is executed. So as here we can see, we have 0C in our accumulator. Now we run our second command, which is MVIB 13. So we have 0D in our B register. So 0D in accumulator in B register is in hexadecimal. So when we convert 0D hexadecimal value to decimal, we have 13, which is right. Now we run MVIC, 05 command. So we have 05 in C register. Then we have add B. Add B will add the content of accumulator with the content of register B, which gives us 19. So in hexadecimal, 19 is equals to 25 in decimal, which is correct because we give 12 plus 13, which is 25. Now we run ADC C command. But before that, as we can see, there is no carry generated, so it not gonna impact the result. So now we run ADC C command. Now we can see we have 1E in accumulator, which is in hexadecimal. So we convert 1E into decimal, which is 30, which is right. Now we store our result, which is stored in accumulator, to the memory location, which is 2000. Now we can check 2000 from here. But for this, firstly we have to execute this. For this, we go to halt command. Now as we search in memory, we can see there is 30 stored at 2000, which is the value stored in accumulator is now at memory location 2000. Now we have halt command to terminate the program. So that's all in this program. If you have any issue, you can connect me through me, or you can write your issues in the comment. So thank you for listening. Do like and subscribe, and have a nice day.